So, Paul, we often find these quasars we talked about in our first course in the centers of some galaxies. And the only way we think we can power those quasars is that quasar to have a giant black hole in the center. So it strikes me that maybe it would make a lot of sense to look at the closest galaxy and at its center and see what's going on there. And that closest galaxy, of course, would be the Milky Way, our own galaxy.
Yep, so let's look at a zoom in of our own Milky Way galaxy from the European Southern Observatory. So there's Sagittarius, showing the stars.
So that's the Milky Way. We're going to go right into the center of it. So we're zooming in, and you're literally looking at 10 billion stars there to begin with.
And as we zoom in, we change our wavelength from optical to infrared because the centre is shrouded by huge amounts of dust and we can't see it at visible wavelengths. But if you go to longer and longer wavelengths, we can see through the dust.
Okay, and what we're going to end up here at the very end is we're going to take an image here where we've made it look very fancy with adaptive optics that we talked about in the first course, where we get rid of the effects of the atmosphere and use an 8-meter telescope.
Yeah, and here we've modelled what you've seen in that previous image. The previous image is the real data,
Yep.
and now we're actually modelling it, so we're trying to fit that. And what you can see is there are stars that on the timescales as 15 years worth of data are actually moving around. If we close in, we can try and work out what sort of orbits are consistent with their motion, and it looks like they are all going around a point over here. So if you see something going like this, there must be a mass there, and you work out how much mass is necessary to explain the motion. If it's accelerating really fast, it must be very massive.
So how much do we need to get those stars to move?
Best estimates are about 4 million times the mass of the Sun.
4 million times the mass of the Sun. Wow, that's
And it must be small because some of these stars are going very, very close. If it was big, like it was, say, a cluster of neutron stars or something, they'd be passing inside the cluster of neutron stars. So it's got to be no more than a few light hours across.
A few light hours across, so that's inside our solar system to Pluto. And 4 million suns worth. So I could imagine packing 4 million suns in that space, but I can't imagine keeping all those suns in there because they're going to collide and there's just really no way to
And if
do
you've got that
anything
much mass, the event horizon is going to be an astronomical unit or so anyway. So it's
Okay, so it sounds like this is a smoking gun for a black hole.
Yep, that much mass, not much light coming out, a huge amount of mass, small space, that certainly sounds like a black hole.